Okay, so you guys can download this handout online. Okay, what we're going to do is just take one day to do a little crash course Algebra 2 skills. Factoring, we reviewed it a little bit. We didn't need it a whole lot yet. We are a lot more in 1.4 and a ton in Chapter 2. So we're going to insert this one day review of factoring and solving quadratics. Okay. Don't overlook this. If you don't have these skills, remember, this is usually just parts of a problem this year. In Algebra 2, a lot of times it was the problem. All right, but we got to move forward and start using this in parts of our problems. All right, so this is going to serve as our notes and our assignment today. I'm going to put in some examples right up here. I want you to follow along and do the same thing. And then we'll try it down here for practice today. All right, so this side is all about just factoring. And then on the other side, we'll use some factoring to solve quadratics on the back. Okay, all right, so GCF. Here's an example I want you to put down. All right, so 27x cubed minus 9x squared is the example. All right, now either in your brain or on paper, we can take the time to break down these factors. So I want you to just do it here this first time, and then I'll leave it up to you whether you want to show the factors for these every time. Okay. So for 27x cubed, what do I have? What are my factors of 27? I've got 3. We can ignore 1. 3, 9, 27. X cubed is x, times x times x. Okay, what about for 9x squared? This is 3, 9, x, and x. Okay, so I don't want to just look at the common factor. I want to look at the greatest common factor, because 3 is a common factor. Okay, but the greatest common factor for the numbers are 9. And then what do I have in common with the variables? X squared is in common. So 9 and 2x's being multiplied becomes the GCF. Okay, so 9x squared is identified as the GCF. All right, simply put, this is one of the easier factoring techniques, I think, because you're just practicing the distributive property. Take 9x squared, put it out in front of the parentheses, and put enough spots for the number of terms you have above. So we just kind of fill in the blank. 9x squared times what gives me that term above? I'm going to need 3, and I'm going to need x to get the x cubed. 9x squared times what gives me 9x squared? Well, we know we just need 1, but there's a minus there, so that would make sense to have a minus 1. And we just factored out the greatest common factor. Okay? On to the grouping method. Try to write small here. We kind of need like 3 lines of work to show you this. Almost 4, but I'll scoot over this way. All right, let's take a look at this one. 8x squared minus 10x minus 3. So we call this a quadratic trinomial. Second degree, 3 terms. Okay. So what we need to do here is I create this little chart just to help us to brainstorm. So I need factors of A times C, but specifically the ones that have a sum of our middle term, B. Okay, so factors of A times C that have a sum of B. So what is A times C for this problem? It's the 8 and the negative 3, okay? So what I want to look at is I'm going to try to squeeze in a little table here. Factors of negative 24, but they have a sum of the middle coefficient, which is negative 10. Okay, so we're kind of thinking through. Maybe the first thing that pops in your head is a negative 6 times 4. That does equal negative 24, but when I add them together, that gives me negative 2. Nope, not working. Okay, so negative 12 and positive 2 do work. Those are factors that now we're going to add up to negative 10. Okay. All right. Now what I want you to do is to take those two numbers and siphon this through. Okay. Before I continue, by the way, factoring quadratic trinomials, there's like 3 or 4 different ways you can learn how to do this. I know Mr. Miller taught grouping. I think Mrs. Pins taught grouping, but Oski said she did guessing and checking, which is fine. If you're more comfortable with guessing and checking on this, I think it takes longer, but you're more than welcome to do it as long as you get it right. You don't have to do my method, okay? This is just my strongly recommended method, because then when we get to problems that are cubic later on in chapter 2 like this, we're going to factor this by grouping too, and it's a very easy transition if you know how to do it, okay? All right, so continuing on with grouping, if this is your method of choice. Once I find those factors, I'm going to use it to split up my middle term. I'm just going to rewrite it. 8x squared stays the same. So I'm going to write minus 12x minus 2x now, or vice versa. It doesn't matter which one I write first. And then I still have the minus 3. That's kind of the toughest part of the problem, is taking the time to do that, get the right factors, split this up. Because now I'm just going to factor out the GCF out of each group. That's why it's called grouping. GCF out of each group. So this first group, I'm going to take the GCF out of that and out of that. So what's the GCF of 8 and 12? It's 4, and then I can take an x out. So I'm going to put 4x right here and fill in the blank. So 4x times 2x is 8x squared. 4x times minus 3 is 12x. Okay, this next group, whatever sign you have in front of that group has to come down. So this is going to be a minus. And if I don't have anything I can take out, I at least have to take out a 1 in this process. So I'm going to take out a negative 1. So negative 1 times 2x gives me this. And then negative 1 times positive 3 is a negative 3. Okay. All right, just caught an error I made. When I transfer these numbers over, negative 12 and positive 2, I did a negative 2. So let's fix this right now. This is a positive 2. So the sign that's transferred down is a positive 1. Okay? All right, so then as we check, 1 times 2x is 2x. Positive 1 times negative 3 is negative 3. Okay, sorry about that confusion, but it's fixed now. Okay, and if we're doing this right, these are common, which is why it's noticed it was a mistake, because I didn't have these as common. 2x minus 3 comes out of both of these now, and then this is our final answer right here. Okay, so 2x minus 3 comes out of both of those factors, and then what am I left with? The 4x plus 1. And it's factored, just like that. Grouping method. Factors of A times C, that add up to B. Once you figure that out, we split the middle term and factor out the GCF. Okay? I want you to try one like that while it's fresh in our memory. So I'm going to pause here and find one for you to do. Hold on. Number 5. Number 5 down below. Try that right now using the grouping method, unless you were using maybe the guess and check method. In the end, we just have to get it right. Okay. So we're just discussing in class the factors of 24 that add up to 14 has to be 12 and 2. So that's why we split the middle term like this. And now I'm factoring the GCF out of this group. It's got to be 4x. And then the GCF out of this group. It is kind of a lot like the example I went over in terms of numbers. So I took out a positive 1. Now 2x plus 3 is in common. So if I take that out of both of these, what am I left with? 4x plus 1. So my final factorization or answer is right here. And of course, you can always have the 4x plus 1 written first. It doesn't matter. Okay, last factoring method is difference of two squares. All right, so difference of two squares takes on this rule right here, if you remember this from Algebra 2. If it is in the form of a number or term squared minus another term squared, then the quick and easy way to factor this is to write it as quantity A plus B times quantity A minus B. I'll show you two examples of this one. All right, so if I have y squared minus 64, this is considered a difference, right? This doesn't work for sum of squares. It's got to be a difference of two squares. Now, this 64 isn't written as b squared, so if you wanted to rewrite this as y squared minus 8 squared, maybe that'll help you see it, the next step. This will definitely help you on more complicated problems to write it like this, as I'll show you next. So, basically the a is y and the b is 8. So this is going to be equal y plus 8 times y minus 8. Okay, and that's it. Why this kind of works is if you wanted to multiply it to check and see if you did it right. Y times y gives me y squared. Then I get negative 8y. Then I get positive 8y. And then 8 times negative 8 is negative 64. So whenever I multiply an a plus b and a minus b together, the middle terms always cancel out. It's just a pattern that will always happen. So the result is a difference of two squares in the end. Okay, so the backwards approach is if it's a difference of two squares, we can quickly factor it this way. Okay, let me show you one more here. All right, so 36x squared minus y to the fourth. This might be a little bit tougher to see the squares. So if it gets a little messy, I would definitely not overlook this step right here of writing it as a difference of two squares. So this is what I mean by that. How can I write 36x squared as something squared? Well, I'd need 6x in there, wouldn't I? How can I write y to the fourth as something squared? So we got to rely a little bit on our Algebra 2 skills in order to come up with that. Y squared squared, we multiply those exponents. Square the 6, square the x. Okay, so now I have it in the form a squared minus b squared. So this is going to factor as 6x plus y squared times 6x minus y squared. Okay, those messier ones might take a little bit of time, a little bit of practice. I get it. There's an example you can refer back to for problems like 11. 11 is a lot like the one I just did. So try to write that like this when you get there. Okay. All right. I want to move on to a couple examples on the other side. Let's do that now. Okay. These two, we'll wait till we need it in chapter 2. So this isn't, we'll do this later. Chapter 2. We're not going to worry about this right now. Okay. We'll cross that bridge later. These two, though, I've already come up a little bit, and they're going to come up even more. Okay, so here's the square root method. Now we're moving into solving these quadratic equations, not just factoring. We need to solve it. Okay, so let's take a look at this example here. 2x squared minus 50 equals 0. Okay, when you see it's possible just to get x squared by itself, because there's no x term here, right? Like if you compare this to some of these where it had an x term, there is no x term. So we could get x squared by itself pretty easily. So what we're going to do is add 50 and rewrite it. So we get 2x squared equals 50. And pause right here. And the rest of it will be on video 2.